Okay, in this next video, we're going to do this again. We're going to find the function that best models the data at the left, but this time we're going to use our calculators entirely. So I'm going to go back over to my graphing calculator. I am going to hit exit until I can delete my data. So I'm going to practice deleting my data. If you need to press pause, go ahead and do that. I'm going to enter the x values 0, 1, 2, 3, and 4. I'm going to come back over to list 2 and I'm going to enter my y values. I am likely going a bit faster than you because I've got a little bit more experience on the calculator, so I can go a little bit faster. So again, the reason why we're doing this in a video is for you to be able to press pause so that you can catch up. We're going to hit graph, so I'm going to hit F6 until I get over to the graph feature. And this definitely looks like it is maybe exponential. However, there's no way to get a 0, 0 out for an exponential. So let me show you. Y equals a times b to the x. If I put a 0 in for x, there's no way that I can get a 0 for y because b to the 0 is 1. And if a is 0, then all of my outputs are going to be 0. And you can clearly see that all of your outputs are not 0. So a cannot equal 0. We talked about that way when we did back in the exponential unit when we talked about exponentials. So a cannot equal 0. B cannot equal 1, right? Remember, b cannot equal 1. A cannot equal 0, b cannot equal 1. Matter of fact, b has to be greater than 0, but not equal to 1. It's all coming back to us now, right? So this right here, this 0, 0, tells us that cannot be exponential. So this graph must bounce back up. So it must come here and it must bounce back up. So I'm going to calculate, because it's definitely not linear, I'm going to calculate x squared. And look at that. When I calculate the x squared, look at the r squared equals 1. So look at this 0 to 0.3. I'm just writing the y values here because I'm going to mess with them a little bit. 2.7, 4.8. Now remember, the second difference needs to be constant. So 0.3 to 1.2 is 0.9. 1.2 to 2.7 is 1.5. 2.7 to 4.8 is 2.1. Our second difference, 0.6, 0.6, 0.6. That's a second difference. Second difference that's common. Therefore, it is indeed quadratic. So looking at the graph, knowing that about the 0, 0, that we're not going to be able to get an exponential, it's a quadratic function. And our quadratic function, y equals ax squared plus bx plus c, our a value is 0.3. b and c are 0. So 0.3x squared plus 0x plus 0. Well, this is just 0. So our model is y equals 0.3x squared. And that has correlation coefficient equal to 1. So remember that that's our correlation coefficient. And the closer that correlation coefficient, r, is equal to 1, the better the fit. When it's exactly 1, that means it's a perfect fit. Perfect fit. This is a perfect fit. Doesn't get any better than that. Okay, let's try in our calculator again. I think you're ready for a few tries here. So here are our last 3 problems. you're going to try each one of these problems, and then you're going to come on back and you're going to check your answers and your models. We're going to look at your models as an equation. So make sure you're writing down the equation, and also let's figure out what r squared is for each one of those. I think you're going to find that r squared is very, very nice for each one. If you don't have a very, very nice number that's very close, if not perfect, for your correlation coefficient, then you might want to try a different model. Okay, so here we are. We're ready to reveal the answers. So in our first model, I got, when I put this into my calculator, my handy dandy calculator, I got an exponential model. And the equation for that model is y equals 4 times 1.1 raised to the x power. Now I put that b, that base 1.1 in parentheses. The next one, I noticed here that I had a constant rate of change. My x's were going up by 1. My y's, they were just changing by a positive 1/2. Therefore, I realized very quickly, and then confirmed it graphically, that we have a linear model. And the equation for that linear model was y equals 0.5x plus 0.5. And the last one, we have a quadratic function. So in this last function, it was quadratic, and it's y equals negative 0.5x squared. Our b and c value, I'm in the wrong color here. Our b and c value, again, were 0. So those went away, and that is why we ended up with just the quadratic term. So that's a little bit of practice using the statistics feature of our calculator. We have detailed notes way back in the, I believe it's way back in the exponential unit. You should have your detailed notes on how to go through the motions. If this video went a little bit too fast for you, you can recall that using those notes. They're also available on my classroom website.